So this talk is about Jetpack Compose, and it's a declarative UI framework made by Google. It's part of their Jetpack libraries, and it's a replacement for the XML view layout system in Android for Android native programming. So that's the background of the talk. Who am I? I'm Maya Jetpack. I'm an Android engineer at Luno, and that's my Twitter handle. If you want to ask me questions, you're welcome to. So let's see. Slide next. So if you're thinking about an Android app, so just taking a step back, I don't know who of you are Android developers, but all of you have got a phone in your pocket. And if you look at any Android app, what it has is it's got some other state coming from either the network or from a local state. So like loading through a network interface, or you've got local storage over here. And then there's a UI. And the UI changes as the state changes. And if a user then clicks on, say, the pretzels or the cupcakes or whatever, it's an event coming in from the outside from the UI, which then potentially modifies the state. And then the UI is updated again. So using that concept, there's this concept of state flow. So there's what they call unidirectional state flow. So there's this concept of a state that comes from somewhere. It flows down into your UI, and then the events from the UI flow up again. So what we try to do in Android sometimes is to make this flow be unidirectional so that you don't have strange state things happening and weird things, events, short-circuiting this, because logically it makes more sense to deal with state, because state, as we all know, can get pretty complex. So that's just the background for an app and how that would fit together. So if you look at Android, drilling down a bit at how Android does things, I'm just keeping the state diagram over here. The state is like the picture that's coming up onto the screen. The event is maybe the user interaction. So in a classical Android native environment, if you use the Google supplied frameworks to build your app, you would have an activity or a fragment or any combination of these two. You'd have a view model object, which gets persisted over orientation changes or as the life cycle changes. You're interacting with that using a live data, which is like an observable. Maybe you have on the back end of that, you've got a repository class, and what the repository class would do is it would fetch the state from either local storage or the network and then serve it up to the view model. And then to get the view to be what the view is, in classic Android, you would have a layout XML. You would have a way of hooking this, inflating it from the fragment. You'd have a way of catching events, passing it through, and interacting with the view model in this way. And there are different ways to bind with this. So now, where does Compose come in? So Compose wants to replace this piece over here. None of these architecture things. So if you have an app that's built with a different architecture, that would be okay as well. It just wants to replace this UI part with Compose. Okay. So if we look again now at how the views were built in old Android way, you had XML files, and a combination of these XML files, when you started up your fragment, it would inflate and it would build this whole tree, like a nested tree structure of all of these views. And then somewhere in your code, you'd have to find the particular view that you want using something like find view by ID. There are other ways as well, but that's the typical way, find view by ID. And then as your state interactions come in, you would take this view that you found in this tree and set the string. Or if you wanted your user to interact with this, you would set a click handle on a view. But the thing to notice here is that all of the views in your system get inflated as a hierarchy of objects in the beginning when you inflate your view. There are other ways of doing it, but that's the basic principle. So now what are we replacing it with? What we want and what Compose offers is code in Kotlin, functions. They're nested functions. Instead of having this object tree, you have it all in code, and they're nested composable functions, and you're passing your state and your interaction handlers in as parameters in these functions. So these functions aren't necessarily instantiated, they're living in the code, but it will run through the composable functions as the state changes. And then there's a mechanism to hook all of these composable functions onto a UI, which will render the UI, and it knows how to recompose. So the library will give you this recomposition possibility from these functions. They're pure functions in Kotlin. Well, not really pure, but they're pure Kotlin functions that you just nest in this way. It'll become a bit clearer when I show the code, but let's just go over a little bit of it. So how do you do this in Compose? So basically what you do is you add this annotation to a standard Kotlin function. The parameters that come in a state, you can define what the state is. And what this at composable annotation does, it's a compiler plugin. It's not part of an annotation process. It's actually a compiler plugin on the Kotlin compiler. And it passes in an object called a composer as like a hidden parameter coming in here. So all of your composables, if you're building a tree of nested functions like this, each of these functions will get this composer coming in. And what this composer is, it's like an object that has a data structure called a slot table, and it knows what the code looks like inside your function. It also knows the state, and it has some other parameters here to know if the state has changed. So it can see, okay, state changed over here, but no state changed here or here or here. And this composer knows then which of these functions to call again if there's a state change. So for instance, if it's a screen that has the cupcake on, if in here comes something that changes from cupcake to pretzel, the composer can see that the state has changed, and it will only recall this function and then therefore just build a little piece of the UI. So that's a little bit of it under the hood. So you can understand now that if you used to think of like a hierarchy of objects, and now you've got a hierarchy of functions that get called, you've got to kind of think of this differently. And also there's this other player in the room. There's this composer, which does things and decides by itself when to recompose. So this kind of changes the way you think about things. So how do you think about it? What is the things that you can think about that are changing? Well, first of all, it's all Kotlin. So there's no more XML and Kotlin and or Java. It's nested functions. They're declarative. So what it is, you actually just say, I want an image on the screen. You don't say how this is done. You just give, it's declarative in that way. And you need to write the functions without side effects. Okay, there is a way to add in side effects if you need it, but you shouldn't be making things. So you shouldn't have, say, a variable outside here, that if this function is called in here, that this variable gets changed on the outside. You should be doing all of your changes to the state that comes in, or if you need to do an event with an event handler, that also comes in so that the event can get passed out. The other thing to think about is that there's this composer object that decides when these methods will be recomposed or recalled. And it can actually optimize because it knows what your code looks like, and because it knows how the state changes, it can optimize. So you might be writing the code to look like it's running in this order, but it might optimize and run things out of order. It might run things in parallel. It might decide to skip things if state changes or the user leaves the screen. It can decide to cancel. And also, if it's busy animating, it can call a particular composable multiple times as it's animating the frames. So you see, these functions need to be efficient and not have any side effects. Otherwise, you might run into some problems. So now, this is all nice, pretty pictures. Let's look at the code. So what I've done for you is I've made a simple hello world. And if I scroll up here, to people who've coded Android before, you'll recognize this is the main activity. This is typically an activity in a class. And one of the functions that you would override is the onCreate. And in an old Android view system, at this point here, after you've called the super, you would inflate your XML and make the tree of objects. But now, because we're in Compose, there's this thing, set content, there's this method, which actually makes you be inside the compose world, because composables can be called from other composables, but you can't just call a composable from any other method. So if you're inside the onCreate method, you can't just call a composable. You need to actually go into a context where you can. And so the set content over here will give you the context to be able to call composables. I see there's something in the chat. So I think, let me just show this and then I'll stop and we can ask, see if there people have questions. And so what I've done here, this is just a composable for the theme, and here's the composable for the main screen. What you can do in Compose, which is really cool, is have this at preview. And in your preview, you can have exactly the same as what you would have inside your activity. And so you don't need to run an emulator, you can just run the preview. And I'm just going to build refresh here and we can see the preview. Now, let me see if I can see if anybody's got, so I'm going to stop for a moment. And if people have got questions, you can ask questions. Just going to see if there's a chat. Let me put chat here. Oh, okay, it's just someone saying they're double booked. Okay, that's fine. All right. So if you don't have questions, let me carry on. So this is just how I've set it up so that we can see what's happening over here. So now inside my main screen, so this is what's going to appear over on this side. Oh, there we have it. Hello world. So what I've got here, this surface is just giving me the white background. I've got a column because I'm going to use it later. I'll explain that in a minute. And this is a text composable. It's really one of the most basic composables. You don't have to read all of this, but that's what it is. It's got lots of parameters, but most importantly, you can just pass in text and it's going to appear over here. So now let's do something a bit more complicated. Just slightly more complicated. So now we're making our own composable. Here's that at composable annotation. It's just a function. I'm going to pass in a string. It's a text. And I'm going to say my text is, I'm going to like build up the string from the name that comes in over here. And this is the next concept of compose. Each of these composables can take a modifier. And a modifier is like a decorator pattern that allows you to change things, like in this case, or change behavior, like in this case, I can add padding. There are lots of modifiers. I'm just going to press dot, and then you can see what all modifiers can come up here. So you see, you can do all sorts of things. You can add clickables, you can fill max width. There are all sorts of modifiers you can add, change the background color. So all of these are like decorators that you can use to modify what your composable is doing. So I've got this composable, and so inside here, let's just comment out the column so I can show you what the column does. Comment out the column. Let's just put, we want this greeting. And we want to say the name that we're going to pass in is Alice. So now I've added another composable here. So if I build and refresh, we should see it executing this now. Okay, let's take the padding out and then you'll see what happens. So what we have here is we've got two of these composables running, but because there's no column, you can see they're actually drawing over each other. So now if I put the column back and we build and refresh, you should see that they're going. So now you can see what the column does. It actually just builds up a column. One of the other things about previews are that you don't always have to rebuild. So you can see that I changed it updates live for some things, not for everything, but it updates live for some things. Okay. So now if I add the padding over here, let's take the padding out over here. I think this one I'm going to have to build and refresh. So the thing to notice here now is you can see how it's declarative. You just say, I want a column, I want text, and I want more complicated text. Okay, so this is my first sample. So now let's add a list. Now I've prepared some code. Let's see if I can get to my code. So this is just where I'm copying and pasting from. So first I need a label and I want a sample list. Let's do that. So I've made it such that I've got some data for us to use, so we don't have to worry about the data. So now I'm just going to paste in here under my greeting 3 new composables. The first is this label list, which is just a text. It's like that greeting. And the second is this sample list. And the sample list takes a list of things and it will show in a column this list of entries. And it's literally just going through each of the entries and writing the label to screen. So if I go here and I add here sample list, you can add your own list, but I've got some canned data that should appear. And so now we should see shortly while it's rendering. Okay, so here we see this list. But what I want to show you now is if I just zoom out a bit. The problem here is there's more information here, but it's only drawing the things on the screen here because this is just a column and the column will just fill the screen and then there. So you can't scroll. So in old Android, you would use a recycler view, but in Compose, the other thing about the composer is it knows that the rest of this data is not on the screen. So it's going to optimize and possibly not even call the rest of this data. So let's go back to my little sample again. And I can cut out my LazyList. So here is an example of how you would do LazyList. Go back here. And let's replace my sample list with a LazyList. So what the LazyList looks like, there's a thing called a lazy column. And it has an object, the items, and you say the size of it, and then you can build the same list like that. You can get this out of the entries. There's the entries coming in. You say to the lazy column, I've got so many entries, and then you can just display it like that. So let's see what that looks like. So this is sample LazyList. No, sample LazyList. And let's reload and refresh. And again, you can see I've got a column on the outside and it's nesting. I've got this text nesting and then I've got another column nesting inside there. So the way that you build this up is by building up these nested function calls, nested composable function calls. Is this building? Build? Ah, there we are. All right, so now theoretically, if I click and I drag, this should click and drag. Why is this not dragging? Sample LazyList. Sample LazyList. I should have draggable columns. Oh, I know why. I'm not in interactive mode. So this preview can be in interactive mode. And then, there we are. There I can drag. So you can see, and it will just render lazily until it gets to, and only show on the screen the pieces that it needs. Okay, so now let's do something a bit more complex. Let's build a card. Now, when I said to Otto last night, let's build a card, he said, what's a card, Maya? And a card is something you get in the material design system, but basically it is like a box with a drop shadow. I'll show you what it looks like. Let's put it in here so we can see it. And it's just a component you can add. So this card over here is just a card that gets provided, and it's just, if you think about it, it's like a little piece of paper that's on your screen, and you can put anything inside a piece of paper. So sample card, I'll call sample card. And the way I want to build this card is it needs to have a title and it needs to have some description, a short description and a long description. So it's going to ask for a short description and a long description. Okay, now I have some data for us here. Let's just get the data. Here's the sample cards data. Let's Get that. So I don't have to type all of that in. Go back here and we put it in here. And uncomment this. And we should be good to go. Okay. So that's what I want the card to have. It needs to have a title. It needs to have a short description and a long description. Let's build and refresh that in the background. And let's have a look at it here. So the card here has a title, a short description, and a long description. It's just strings that are coming in. So what we want is a row. There's the card. I don't know if we're seeing the card here. We might not be seeing the card yet. And the columns like that. So there'll be a title and a description. So let's just start populating that. Sample card. Let's do this first. Title and text. Let's put inside the title goes here, the description goes here. Okay, expanded is red. I'll do that in a moment. And then I'll put an image in over here. Image goes here. And there's one more thing we need the state. And I'll tell you about state. Now you can either pass the state in from the outside, or Compose gives you a way to have state in your own, in your composable. So what we've got here, we've got a parameter, which is just a Boolean, but we need to tell the composer that this is actually a state. So it's wrapped in a state object. We're setting its initial value to false. And we need to tell the composer that this is a state that you need to worry about. Otherwise, it's not going to track it to know when things need to be recomposed. So this should be compilable. Maybe it's not aligned, but it should be compilable. Let's build and refresh and see if we can start seeing a card. You can start thinking of questions. Build and refresh.
How do you change the color of something?
That's a good question. I can show you. Oh, am I even calling this card? I am calling this card. Why is it not showing up? Maybe the card needs to be full max width. Okay. The color you can change. Some of the composables have color as part of their parameters. And some of the composables you can change the color from a modifier. So if you want to change something like the background color, you can change it from a modifier. Or something like the text. I've got the wrong card here. Why is this red? Okay, I need to just go figure out why this is red. Ah, that's why. Opt in. That's why it's red. So in this modifier, one of the things that the modifier here has is dot background. And we can have a look and see if we can change that. And you can get colors from two places. You can either have them fixed, or you can get them from the resources, or you can get them from the theme. My demo. Murphy's got my demo. Come demo.
Take out the column.
Which column?
The lazy one.
Okay. Take out the column. Refresh and bold. Ah, there we are. Okay, so there's our card. So what you can see here is we've got a row. So there's the row that's got this element and then this. And then inside the second part of the row, we've got a column which is sitting. So rows and columns are just like linear layouts in the old Android system with vertical and horizontal, except that they're split into rows and columns like this. And what we have now, because we've got this modifier here, if you look at this modifier here, it's got an on-click method. And what I'm telling it is to take this Boolean, this expanded Boolean, and just setting it to the opposite. And it's setting it to the opposite. And because the composer is tracking the state using this, remember, if you tap it, it should go bigger. So it'll re-render this composable because now we've got bigger text, and then flip back again. Now, the other thing to notice is you can see that it's growing like slowly. So it's actually animating. So it's on each frame, it's recomposing. And the piece of code that's doing that is not in here yet. So that's interesting. Why is it doing that? Okay, there's an animate, there's a way. Ah, there it is. So here, this text, this bottom text, has got on its modifier, one of the modifier possibilities is this animate content size. So animate content size, like if I comment that out and we refresh it, you'll see that it just snaps open and closed. So this is a good example of a modifier. Watch, boom, big, small, big, small. Now I've set this animate content size to be a tween of 1 second, but let's make it even longer. Let's make it 3 seconds, then you'll see what it looks like when it does that. Hold and refresh. And then we're going to change the color on something, and then I'll show you what the color change looks like. Hold and refresh. I don't know if my big IDE, so I can't see if there's any messages that it's telling me things. Okay. So now you should watch slowly over 3 seconds, it's animating. So the one thing about Compose is they built in the animation parts as part of the APIs. And the animations are actually pretty easy to just add in anyway. You wanted a color change, let's see, full max width, dot background. I think I can do background, yes. Background, and we want color dot magenta. Hold and refresh. Should be pink now. There we are. Okay. So this is interesting. It's making the background of the card pink. It's not making the card itself pink. Okay. Let's move this into the row. Okay, I don't want to go messing with it with a card now. I'm going to go off into a rabbit hole, as it were. The other thing I wanted to show you is I have another sample here. This is a composable that shows either a heart or a diamond, depending on if you pass in a Boolean. Okay. Let's put it here. I'm going to take the magenta out. Let's put it over here. So it's going to show, it's looking at the Boolean coming in. It's going to either show a heart or a spade, not a heart or a diamond, a heart or a spade. The thing I can show you here is before with text, we only added text, but you can actually add code in here and you can change the style. So this material, theme, typography, headline, large, this comes from the theme. This is also just a composable that gives you this theme. And there's our modifier padding. Now I think this can have, I'm not going to change the color. So this is the card that I want. And now I want to embed that in a thing which is swap card. So swap card. So what swap card is going to do, if you click it, it's going to swap to the other one. So here. So if you click it, it's again, there's the state, mutable state false, and we're telling the composer to remember this, and show heart will be true false. And here, the on click here is going to swap to the other one. I've got a column, and then there's this red black card, which takes this Boolean coming in, and it will swap to the other one if you tap it. So I'm going to replace, I'm going to comment this out. I'm going to put the swap card in here. Swap card. Let's go and refresh. How are we doing for time? Half an hour. Okay, so here you can see a little card. It's not full max width. If you tap it, it shows you the other one. So again, we've got events and we've got state changing, and we've got the composer tracking the state and deciding to redraw. And now just to show you how easy it is to add some animations, I have a crossfade card, which I'm going to put in here. Swap card. It's a crossfade card. And so how this is different, instead of over here at this bottom one, instead of over here where we were just calling this red black card in a column, we're now wrapping this red black card in this crossfade composable. And it says it needs to use this Boolean to decide which of the two states it's in. And again, I'm setting the animation to be 3 seconds, so it goes nice and slow so we can see it. And then it's got this lambda with the Boolean coming in, and I'm using the same red black card composable to show it. So let's see, this one is called crossfade card, and we'll replace swap card with crossfade card. Bold and refresh. We can actually have both of them next to each other. Let's see. So there, now you'll see it should take 3 seconds. Huh? IDE is complaining. We're going to just tell it. So you'll see now it's doing the animation slowly. Let's do swap card next to it so you can see. Swap card like that. Split. Rebuild. So we should have the non-animating one above the animating one. There's swap card, and it just clicks, swaps through, and this one does a slow fade across. So the theme to notice with all of this is that you have these functions and you can nest the other functions inside of them. And you can quite easily modify things or add things by just nesting the functions differently. Okay, so that's the end of the demo. Does anybody have any questions about the code or anything you think we should try, or you want to see how we can try something else on the Android side here? No questions. Then I've got another demo for you.
Yes.
Yeah.
Which versions of Android Studio do you need for the Compose?
Arctic Fox. I'm on Bumblebee at the moment, or Chipmunk, but you need Arctic Fox to be able to do Compose. And you need compiler version. I think the latest stable Compose is on Kotlin 1.5.31. So if you've got the wrong compiler version, the plugin won't work properly. So the other thing I wanted to tell you about, there's a thing called Compose for Desktop. And so the way they structured the libraries is pretty clever. They made it such that you don't need to run it only on Android. You can also run it in this Compose for Desktop. And I'm just building the project. And basically what I did is I copied the code that I just showed you, which was running on Android, which could also run in an emulator. And I copied it into a pure Kotlin project, a Compose for Desktop project, and those libraries are also available. So here you can see there's my card, which does the same thing with a slow expand. And this is a desktop app. And these desktop apps can run on Linux, Mac OS, and Windows. And we should get a slow fade. The emoji over here isn't the red one, it's the black one. And then here we should have a scrolling list working in the same way. So all of the things we just built for Android, you can equally build on a desktop app. And the code looks the same. So if you learn it for desktop, you could apply a lot of it to the Android world, or if you learn it for Android, you can use that knowledge. The thing that's slightly different with desktop is, of course, the touch targets aren't exactly the same, and they have a thing, there's the mouse and hover. So there's some of the desktop things that are slightly different, and you can't access any of the Android things, like you can't access Android resources. You have to get this picture in a different way, or you can't. And the other thing the big thing that's different is that a desktop app doesn't have a complicated life cycle like Android. It just has window open, window close, which is much easier to handle than the Android ones. Okay, I'm going to switch back to my slides. So I showed you the code.
These standalone applications, when you compile them for desktop, do you have different executables for different platforms, or is it just a single?
No, it's different ones. So there's a DMG file for Mac, there's an exe for Windows, and you can tell it which package if you want a .deb or whatever your Linux thing is. So part of the Gradle tools for desktop, Compose for Desktop, is Gradle tasks that will let you generate those executables that you can use across platform.
And what's the performance like on a desktop compared to a phone?
I'm getting, it's snappy enough. I mean, it's like, this works okay. I think it's running on an embedded JVM. It's a JVM, it's built on top of the JVM. So it actually has a way of like including whatever runtime it needs as part of the executable. And JVMs in general, they're not too laggy. They're actually okay to run. So I'd say the performance is fine. I think it's probably better than something where you have to have like Electron, where you have to have a whole Chromium that's like an embedded browser. This looks like it's slow, but that's just because I've put the animation at a few seconds. But the performance is, I think you could potentially have better memory footprint and better performance than something that was written in Electron where you have a Chromium browser embedded. Okay, more questions? So what my impressions of it, it's declarative, which is a different way of thinking, but quite refreshing. It's pretty easy to add things, and there are lots of places where you can copy existing composables and get composables with libraries. What they've really paid attention to is that the common cases are simple. So the default parameters of the composables that the libraries provide, you don't even need to have them. You could see with the text, you could just add in text, even though text has a lot of other parameters. So the defaults are pretty good, but because they've got those default parameters, it's really easy to tweak things. So it's really easy. It was really easy for me to get started to just drop in a text, drop in a column, drop in a row, and build something that looks actually pretty neat and pretty complicated. And there is a companion app for that. I'll share the link afterwards too. And now I'm happy to take more questions. I'm going to stop sharing. I'll be back on the screen.
I have a question. So when we started with our Android app here at the office, at the beginning of this year, or close to the beginning of this year, O2 wanted to use Compose for the app and just rewrite it for Compose, but we found out the support for Wear OS was not great. How is the support for Wear OS apps at the moment with Compose?
I'm not sure if it's unstable yet or if it's in beta, but it's on the roadmap. And so if it isn't unstable yet, it's going to be stable shortly. So they're definitely working on it actively. So that's going to come up shortly, hopefully.
Okay, cool.
I can get the exact dates for you and give it to you afterwards. I don't know them off the top of my head.
Okay, so I think I have a few questions.
Those
compose functions, is there any preferences on how deep the view hierarchy can be or how complex it can be inside of it?
Okay, because you're not building a nested graph of objects. So it's not like those objects take up memory, and it's not like you need to build that ahead of time. There's no limitation on the depth. It's just the way that your code is run. It's just like you don't have a limitation on how many nested functions you can call in your code.
Okay, because I know it's like in Flutter, you can do the same, because the declarative way is pretty much the same how you lay it out and all that. But Flutter prefers it to be broken up into smaller pieces and smaller widgets, so it can better manage the state of those. And when it redraws the stuff, if it redraws, it's smaller.
Yeah.
So then my next question is, if you have a complex hierarchy inside of one function, so you have multiple rows and columns and images and stuff in there, when it redraws that function, does it know to only redraw that one text field inside of it, or does it redraw that entire function?
Okay, so it wants you to, the suggested way of doing it is to make separate composables, the same way Flutter does. But that composer, the way that that annotation works is actually pretty interesting, because underneath, it'll go inside your code. So say you've got an if and an else, it actually puts markers there and the code blocks they're actually marked with IDs by themselves, and it actually knows about subsections of your logic. So it knows if the state changes, maybe it needs to do the if part of the block, or if the state changes the other way, it needs to do the else part of the block. And it's got IDs like that, and those IDs are stored in that slot table. So it can optimize for running through pieces of code like that.
Okay, so it's probably doing a reference lookup underneath, like we used to do with the XML stuff. Okay, I think that answers my next question as well with a garbage collector. So if you have a function with a lot of views in there and had to redraw everything, that's going to create a lot of garbage. And as we know, the Java or the Dalvik garbage collector does not like that, and pauses are going to get quite big.
Yeah.
And especially if it gets to Wear OS, where we are resource constrained, that would have been quite a performance hit.
Yeah. So the interesting thing about the Compose runtime library is all that it does is it builds like a tree structure that knows about state. It doesn't know anything about views at all. It's just that functionality that builds the tree structure. On top of that, Android has hooked up its normal view system, and Desktop Compose has hooked up whatever it needs to do its views. So it's separated like that. So underneath the hood, there's still the Android view system that's actually hooking up to it. It's just being created and built optimally from Compose. I mean, you can do things in Compose, obviously, that's going to cause lots of objects and garbage collection if you just use it wrong. But it's pretty clever in the way that it knows how the state changes. It can, the other thing it can optimize for, because it's got like flags that knows if the state that comes in is dirty or not. And it can see if it's a static thing. So, and because it's a compiler plugin, it can actually run more compiler optimizations afterwards. So if those strings that you passed in were static strings, it wouldn't even know, it would know that that state can't even change, right? And optimize like that.
It's similar to Flutter as well. We can use constants and stuff to hint to the compiler that stuff won't change that often. So it can manage it in runtime when it draws and stuff. Then just one last question. How easy is it to migrate from the normal views or the current views to Compose?
Okay, so what they've done is they've made it really super cool interoperable. So there is a thing called an Android view. So say, for instance, you have a map view that's like Google Maps, and that's in an old view system, but your whole hierarchy, your whole screen is written in Compose now, but you want to put this piece of map in there, and that's an old one. There's a composable called Android view, and inside that composable, you've got methods to just inflate your old view. So it's completely possible that if you have your whole screen in Compose, you can drop in an old view in there. Conversely, if you've got a whole screen that's in XML, but you've got a new composable flashy button that animates, there's a new view called Compose view, and you can put Compose view inside your XML. And then when you're in your fragmentor activity, you go find view by ID for that Compose view, and then you just go set content and do all of your Compose stuff inside that Compose view. So it's very easy to embed Compose views inside old Android, and it's very easy to embed Android views inside Compose.
Okay, that's very cool. So I think if this is available on Wear OS, it would be quite good to move our stuff over to this. If there's no performance impact in just having the hierarchy and redrawing everything the entire time, cutting the time that we need to inflate those XMLs, specifically on those small devices, is going to help a lot.
Yeah. Okay.
Thanks, Maya.
Cool questions. More questions. Anybody else?
I see in one of your early slides you had a fragment in there, but I didn't see it in your examples.
Okay, I just put the fragment in there. You don't need the fragment. If you want to do it all inside the activity, you can. But both are supported. You can have it in either the fragment or in the activity. So you would just use that set content that I had right in the beginning. There's a similar one for fragment that you would just use. And that's just like the gateway to come from the old system to the new system.
Yeah, but I mean, you can, in Compose, you can do the same stuff you did with fragments earlier, can't you? Without using fragments.
I mean, like navigating.
Yeah, and reusing and stuff like that.
Yes, yes. So each of those composable functions, they're really cool for reusability, because you can put that little card or you can put that thing in everywhere, so you can reuse it like that. And so you would break up your screen into composables to make those pieces reusable. And there's also navigation libraries that you can use to make it switch between. It's built on the Android navigation libraries, the Jetpack navigation libraries, but they're supported for Compose as well, and they've got animations as well. So you can navigate. So if you had a composable that's filling the screen, which is your first fragment, say same as the fragment, but you don't need the fragment, you can make it navigate to the second screen composable or the first screen composable. And then that screen would just be a method. It wouldn't be a fragment.